talked about the atom in respect to the fact that it has a nucleus. That nucleus has protons and neutrons. Circling that nucleus in major energy shells, we have what? We've got those negative electrons. So this week we study what are those principal shells of energy. What do they have inside them? What are they made of? We've got three different parts. A principal shell has subshells, which is a certain level of energy. Subshells have orbitals, and orbitals are individual shapes or paths. So let's start with the first principal shell. So I've got my nucleus right here, which has protons and neutrons. And here is that first principal shell, n equals 1. That principal shell happens to have an S subshell. So any sphere circular shape we call S. That first shell, this is it. It just has an S subshell. So we'll put that right here, subshells. The first shell just has an S subshell. The second shell happens to have two principal shells, or two subshells, I should say. It also has an S, and it has a P. The P subshell has three parts. To make that subshell, we put those three parts at right angles to each other. So here is our three-dimensional P subshell. The second shell, once again, has an S subshell and a P subshell. So if you can imagine the center of the atom right here, having this subshell go around it and the P subshells going around it. That second shell, we have S and P. Alright, the third shell, do you pick up the pattern? First shell is one subshell. Second shell has two. The third shell, guess what it has? If you guess 3, you are right. So that third shell also has an S subshell. And it also has a P subshell. Here's the three pieces. But it has one more subshell. It also has a D subshell. That subshell has 5 pieces. I'm not able to do it, but once again, these 5 pieces would be at right angles. So that piece, or D subshell, would be 3-dimensional. So that third shell, we've got 3 subshells. We have an S, we've got our P subshell, we've got the D subshell. Alright, we can keep going. We name subshells, we just use consonants. So we've got S, SP, SPD. Pick this one, we have to have 4 subshells. SPD, F. Fifth shell, we've got 5 subshells, SPD, FG. Sixth, we've got 6 subshells, SPD, FGH. The seventh shell, we have 7 subshells, SPD, FGH, J. Skip that I. Just so happens that we don't have any elements with more electrons than what can fill up to 7s. So in that 7th shell, this does not get used. Right, so here's our subshells, our sub-levels of energy. But within those subshells, we said we have orbitals. An orbital is the path that an electron can be in. This particular subshell, the first subshell, just has this. So This is it. This is the only path that that electron can have. That subshell just has one orbital. 2s subshell, same thing. It just has one path, one shape. That 2s can only have one orbital. But look at that 2p. The 2p has three shapes. So each shape is an orbital. That means that the electrons have three different shapes that they could be in, or three different paths. So that p subshell has three orbitals. The third shell, here's the s orbital, same thing. Since it has just one path or shape, it just has one orbital. P subshell, same thing. It has three shapes, or it has three orbitals. That D subshell happens to have five shapes or five orbitals. Alright, so look at that pattern. Anytime we have an S, it's just a single shape. So it's just one path. Now, what's the difference between the S's? This was our 4s subshell. The difference is in the size, because if this is the nucleus sitting here, to get to that second shell, it has to be bigger, it has to cover more space. To get to that third shell, same thing. It has to be bigger and cover more space. So as these subshells get further from the nucleus, they have to be bigger. Alright, so we can just keep going. This has one subshell, this has three, this has five. So guess what the F subshell has? It has 7 shapes. Guess what the G has? It has 9 shapes. Guess what the H has? It has 11. And if we had J, it would have 13. Alright, now let's look at how many electrons can be in these subshells. To start with, each shape can only hold 2 electrons. That's because electrons are negative. If we have 2 negative charges get close to each other, what happens? They push apart. So electrons have to have space to stay away from each other. So this will hold 2 electrons. This holds 2 electrons. This one holds 2. This holds 2. But this one, since we can have 2 per shape altogether, this subshell can hold 6. 2, 4, 6. So the individual orbital can just have 2, but put these together to make our P subshell, and it can hold 6. Right, the same thing happens here. Those electrons stay as far apart as possible. So if I have one here, the second one will be up here. So P subshells can hold 6. D subshells, since we have 5 different orbitals or paths, can hold up to 10. 2, 4, 6, 8, 10. Let's put that down. S subshells, which are these circle, can hold up to 2. So right here we have 2. P subshells, since they have 3 different shapes, can hold up to 6. D subshells, since they have 10 different shapes, or 10, since they have 5 different shapes, they can hold up to 10. Get that pattern? This right here, we've got 2, 6, 10, so for every subshell we can hold up to 4 more electrons. So let's add these up. The first shell can only hold up to 2. The second shell can hold up to 8. The third shell can hold up to 18. The fourth shell, let's check it out. This is the S subshell. It can hold up to 2. The P subshell can hold up to 6. The D can hold up to 10. And the F, we add 4 each time, can hold up to 14. So if I add those together, I get 8, 18, 28, 32. So we could keep going with the rest of those shells. Alright, so once again, what's the difference? If it's a 2p subshell or a 3p subshell, the same shape. It's just that the 3p happens to be bigger. It has to be out to the third shell, so it has to be bigger. The 2p subshell only has to go out to the second shell. The 3p has to make it out to the third shell. So anytime you see an S, it's this shape. And anytime you see a P, it is this shape.